Now we're going to look at how we would find formulas for quadratic functions. There will be two cases we will be looking at. In the first case, we will know the vertex and one other point, and in the second case, we will know the zeros and one other point. So let's take a look at case 1. We know the vertex and one other point. When we know the vertex, so again, when I know the vertex, what I will do is I will use the form that's f at x equals a x minus h squared plus k. And that's what the notes say. But when I know the vertex, that's what tells me to use that particular formula. So I have two steps. Step 1 is I substitute in the vertex into this particular form, and then I substitute in a point for x and f at x, for x and y, and that will allow me to solve for a. So here's an example. Suppose I want to find an equation for the quadratic function drawn below. As I look at this, when I go to take a look at what the vertex is, what I learn is that my vertex is at 3, 2. And so with my vertex at 3, 2, I get f at x is a multiplied by x minus 3 squared plus 2. So that's my step 1. I just found the vertex and substituted in. Step 2, I substitute in another point. Typically we'll be given a point, but I'm going to read a point off the graph, and I'm going to read off the y-intercept, which is 0, 8. So I substitute in 8 for the y and 0 for the x. And if I do that, I get 8 equals 9a plus 2. And then I just solve that, so I'd have 8 minus 2 equals 9a. And if I do that out, I get a equals 2/3. And I just write the final answer. F at x equals 2/3 multiplied by the quantity x minus 3 squared plus 2.